buildings in Chicago are basically heated in one of two ways. Well, you can heat them with electric too, but it's either steam or hot water for the most part is what you're going to see. And we'll be covering the steam and hot water side in this seminar today. But the first thing I want to talk about is, boiler, you should have your boiler serviced annually. Most of the boiler makers in their manuals, they're going to have a maintenance schedule and program and whatnot that they want you to follow. And often the boiler gets ignored and it doesn't get serviced until there's a problem. And that in itself is a problem because you can probably avoid that altogether if you just follow the maintenance requirements that the manufacturer spells out. What I'm going to do today is I'm going to kind of bring all the manufacturers together and kind of as a general rule of thumb, this is what most of them are asking for and what you need to do. Some of the stuff I'm going to talk about today, if you're not a contractor and you haven't been trained in certain aspects of boiler maintenance, you might not want to do that. You might want to call in a professional and ask them to handle certain aspects of what I'm going to talk about today. But a lot of stuff I'm going to talk about today, you guys can do yourselves. So there is going to be a little bit of both here.
Will you make clear which is which?
Yeah, I will. I'll try to make that clear as I go along. But if you do get your boiler serviced annually, one, it'll be more reliable, more efficient. So it'll actually save you money. Even though you're going to be spending some money to have it serviced, in the long run, it's like getting your car tuned up. You'll get better gas mileage out of your car if you get it tuned up. You'll get better efficiency out of your boiler if you get it tuned up. And the other thing I always just talk about is, carbon monoxide poisoning is a big problem. And no one obviously wants that to happen. But if you don't maintain your boiler, there is a chance that something like that can happen. That's kind of a worst case scenario. And I throw that in there just to get your attention, because it is a serious problem if it happens, and it can obviously end in some bad things happening like death. So you want to take your maintenance serious. You don't want to just ignore your boiler and wait for something to happen. You want to be proactive rather than reactive. When we talk about boilers, like I said, we're really talking about two types of boilers, steam or hot water. Okay, that's what you're going to find in the Chicagoland area. And there's categories of boilers. There's different styles and types. Some of them are just atmospheric. They're just basically on-off. They'll have a big vent hood on top of the boiler. And it's just basically when there's a call for heat, there's an Aqua Stat in the boiler, and it's going to measure the temperature of the boiler. And if it's not hot enough, it turns the flame on, and then the water in the boiler gets heated. And a circulator will turn on a hot water system. In the steam system, there is no circulator. Forced draft is a fan assisted. These are going to be a little more efficient than your atmospheric. Atmospheric boilers just use the natural draft of heat. So when you turn that flame on and you heat that fuel and air mixture, you know how hot air rises? It just rises right up to stacking out. There is nothing to help that flue gas out of the building, okay? That's what an atmospheric boiler is. Forced draft actually is a fan, and it's blowing through the boiler, across the burner, pushing the flue gas out of the building. Okay. One thing you got to be concerned about with atmospheric and forced draft is if your building goes negative. And negative is the pressure inside your building, depending on what's running, like for instance, exhaust fans, even on stoves and stuff like that, or in bathrooms and all that. If there's enough of that going on, you can actually pull a negative inside your building. And what that means is the pressure inside the building is lower than the pressure outside the building. So in an atmospheric boiler, you can actually pull that flue gas back into the building because the building's negative. Easiest way to tell if you got a building that's negative is stand by a door and see which way the air goes when you crack the door to the mechanical room. And it'll tell you which way your air is flowing, whether it's flowing out or flowing in, to give you whether you're negative or positive. Now you're seeing more in the marketplace they call modulating boilers. And these boilers, basically what they do is they have a fan like the forced draft, except now that fan modulates up and down based on the temperature of the water. So what they can do is you can take a boiler that can produce 1 million BTUs or 500,000 BTUs, and they can lower that fan rate down so that it's only putting in 100,000 BTUs into the water. And it's, what you're trying to do is on these days, well, today's not a typical day for this time of year, but normally a day like today, you know, would be what they'd call the shoulder months, and you really don't need a lot of heat, but you might need a little bit of heat at night, you know. But you don't need your boiler full on giving you all the heat that you need when it's 20 degrees out or 0 degrees out. So this way, these boilers modulate based on the outside air temperature so that you don't waste energy turning on that 100,000 or that 1 million BTUs when you only need 100,000. And that's what modulating boilers are all about. And your burners are different for the different types of categories of boilers. So your atmospheric burner is going to be different than a power burner, which is going to be different than a tube style burner. And they all, typically what we're going to find is your tube style burner is in these two types of categories, and then your atmospheric is just like you do, it's just a flame right underneath the heat exchanger. You can actually see it. It's just a tube of flame that's right underneath. Power burners are more bigger, and they're really not in the residential market. But if you look at where boilers, we said we got steam and hot water, and they come in different flavors. A lot you'll see cast iron. That's what was always installed in the past. And those are typically atmospheric boilers. They're not super efficient. And when I talk about efficiency, efficiency is given a rating. You know, so like 80% efficient. You've seen the appliances 70% efficient, or 90% efficient, or 99% efficiency. That's how we rate boilers. Cast iron atmospheric boilers are going to sit around 80% efficiency. They're not super efficient, but they're just basically on-off type boilers. Then you can have steel tube, copper tube, or condensing boilers. It's just a different type of heat exchanger. Rather than a cast iron heat exchanger on your cast iron boiler, which is this, you're going to have steel tubes inside or copper tubes inside, and that's what separates the hot combustion gases from the water. So rather than having thick cast iron, you have thinner steel and copper, and the heat transfer is quicker. And they're more efficient because they can transfer those BTUs from the flue gas that's burning into the water faster and more efficient. So they'll get into the 80s, 88% type range. And then condensing boilers actually can go all the way up to 99. And that condensing means that the easiest way to explain condensing is if you're sitting on a porch on a summer day and you have a glass of iced tea in the glass, what happens to the outside of that glass? It gets wet. That's condensing. And what it is that warm, moist air is hitting that cold glass, and that moisture in that warm, moist air condenses. And when it condenses, it gives up what they call latent heat. And that latent heat gets transferred into the glass, and that's what melts your ice. Okay, and that's what's happening in a boiler, except believe it or not, the condensation is taking place on the flame side. So you have warm, moist flue gas hitting a cold heat exchanger, and water actually comes out. So think about it. You got flame burning and water present in the same area. And that's what a condensing boiler is doing. But when that condenses, it gives up that same latent heat, just like the glass of iced tea, into the water, and you can get up to 10% more efficiency out of it. And that's how they get into the 90s in boiler efficiency. So that's the simplest way to explain condensing. So in a hot water boiler, you're going to have some components. Imagine this is the boiler. The red is water, even though it's red, but it's a representation of water. Okay, so this is your water chamber. Your burner's going to be underneath, which is going to heat the water underneath. All right, you're going to have a supply going out to your system and a return coming back. And then you're going to have a circulating pump somewhere out there, generally close by to the boiler, that's going to move the water out to the system and circulates it through the boiler. Okay? So then there's going to be an Aqua Stat on the boiler. So there's going to be thermostats in the room or in the building. There may be more than one thermostat in the building, depending on how many zones they have. But that thermostat's going to say, hey, this room needs heat, and turns on. That sends a signal to the boiler the boiler's Aqua Stat to say, hey, I need heat. The Aqua Stat looks at the temperature of the water and says, oh, you're too cold. I'm going to turn on. Mr. Burner's going to turn on. And the Aqua Stat tells the burner to turn on. And the Aqua Stat has a temperature range. So let's say it's set for 180. And it's got what they call a differential. So it'll turn on. If, let's say it's 10 degrees on each side. So if 180 is the set point, it's going to turn on at 170 and turn off at 190. And it'll keep doing that as long as there's a call for heat. And that's how you keep your water, heats the water up, goes out to the system, cools down, comes back colder, and then you just keep that cycle going round and round and round and round. And that's basically how a hot water heating system works. Is that pretty clear? One other thing, if you guys have a question, don't be afraid to ask, because I don't mind talking, but I don't want to talk all this full hour. It'd be nice if you guys have a question or two. Go ahead. What it depends on the set point. The way it works is the Aqua Stat's programmed for a set point. It could be 180, 170, 160, but they have to have a differential. The thermostat in the living room tells the Aqua Stat I need heat. And the Aqua Stat decides whether he's going to turn the burner on, because you could have 180 degree water in that boiler right now. So there's no reason to turn it on at that point in time. But then as that water circulates through that room that's calling, it cools, and then that cooler water comes back, starts cooling the boiler water. Then at 170 degrees, the Aqua Stat says turn the burner on. And then it starts heating the water again. Say that again? Well, so some of them will have what they call Danfoss sells them. They're little thermostats at each radiator that's monitoring the temperature of that radiator. And that actually is going to open and close and let water into the radiator. Somewhere in that system, correct. Yeah, they're automatic now. So they have a sensor in there, and if the water temperature drops, the valve opens. But before that point in time, something told the boiler, I need hot water. You know what I'm saying? Yeah. I'm having a real hard time hearing you, sir.
No, I was just saying that in the older systems, they were individual. The valves would either be manually turned on and off, and now you're saying the Danfoss ones are individual thermostats at each unit. But the newer ones, I'm assuming you're talking about newer systems, have maybe a wire that runs from the thermostat at each room's location to the boiler to tell it to communicate?
Some of the more sophisticated systems will have that.
Okay.
Some of them are as simple as a single thermostat in the building that says, okay, it's cold enough now in wherever that thermostat's located, I'm going to send a signal to the boiler to turn on, or I need heat. The boiler's Aqua Stat gets that signal, checks the temperature of the water of the boiler and says, oh, it's too cold, I need to turn the burner on. And that turns the burner on, and typically the circulator too at the same time. So that starts circulating that hot water. That little valve at each of those terminals that are in each room are separate from the boiler. What they're doing is they're monitoring the temperature of that little terminal unit, and they're actually turning on and off to regulate the temperature there. So you can have different temperatures. You could have the whole system calling. The building, the main thermostat in the building says, I need heat. But all your rooms may not need heat. Some might be warm.
But like in older systems, say in a single family home, the loop would just continue, and then the thermostat would turn off at the boiler, and then as it continues, each individual radiator would draw its own heat as it's needed.
Exactly.
Now they're kind of doing it to make it more efficient by shutting down the system even more at different points.
Yeah, and what they're trying to do is they're trying to balance the heat in the building, because if you got a sunny side of a building and a shady side of a building, the sunny side may not require any heat, just because the sun's coming in through the windows and all that. However, the rooms on the other side of the building are cold. So that's why they're controlling the individual temperatures at those terminal units with those valves you're talking about. The system is still calling. So there's still hot water flowing throughout the system, but it's bypassing some of those because there's no need to heat those rooms, and it's dumping water into the radiators or terminal units that need to heat. And that valve is what's allowing that water to get put into those terminal units. Does that make sense?
It does.
And it's getting smarter is what it boils down to, rather than just say, hey, just turn on the boiler and heat the whole house. Well, the poor guy in the sunny room is roasting, and the person in the other side of the room may still be cold. You know, it's a balancing act is what they're doing there. They're trying to get better control of temperature in the different living spaces within the building is what they're doing there. Did I answer your question?
Yes, thank you.
But a couple of other things that you need to be aware of. There's going to be some sort of compression tank in a hot water system. And the reason you need that is as you heat water, it expands. Okay, so if you don't have a compression tank, you heat the water, it's going to expand, and it's going to pop what they call a relief valve. Okay, and the relief valve is set there at a certain pressure, so if the system gets too overpressured, too much pressure than what it was designed for, that relief valve pops open. Some of them are called T and Ps, which means they're both temperature and pressure. So if it gets too hot on the temperature side, it opens. If it gets too hot on the pressure side, it opens. And then it actually dumps the water right out down the drain. I mean, it dumps it right out of the system. That's typically a bad thing. That's telling you there's something wrong. And what typically causes that is your compression tank got waterlogged. And what I mean by waterlogged, there's a water line here. There's air in here and water down here. Air is compressible. If you ever seen it at your faucets, you'll see these little tubes that come up off of the faucet. They're there for water hammer. They're there to absorb the shock when you turn a valve on. That sudden slug of water that comes out the valve, if you don't have a cushion, it'll bum, 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 and you'll hear that noise. Same thing for a boiler. They're using air as a cushion, so that as that pressure changes, this water level will move up and down, or sometimes you have what's known as a diaphragm tank. They're more common. Compression tanks are the older style. Now they use more what they call a diaphragm tank. And a diaphragm tank has a diaphragm that goes through the center and separates the air and the water. And it flexes as the pressure changes so that you don't pop your relief valve. And it allows you a range to operate, because water is incompressible, so you need something that can absorb that extra volume as you heat the water. And that's what your compression tank or diaphragm tank is. If you're popping relief valves arbitrarily and you don't know why, the system heats up and all of a sudden, boom, you dump out water out of your relief valve, check your diaphragm tank. Your diaphragm tank is probably the ruptured or waterlogged, or your compression tank is waterlogged.
Quick question. For the compression tank, does it get its kind of like pre-designated amount of water in it, or do you have to check something so that it lets in just enough, or?
It actually gets what they call a charge. The compression tank will have a little fitting like a bike tire fitting, where you can put air into a bike tire. A diaphragm tank has the same thing, and basically what you do is you'll charge it to like 12 psi, and then you leave it there, and then the water comes in underneath it, and that's connected directly to the boiler through piping, and it comes up from underneath. So the charge on top is what gives you that flex.
In the case of the diaphragm, most of our buildings have the old compression style tanks.
They'll often have a gauge glass on there that you can see if there's a water line in there. If not, they have to have water at the top, and they can get waterlogged over time.
I know.
And you have to. The only thing you can do typically, if you don't have a fitting to put air in, you drain it, and then let the water naturally go back.
And last question: is installing a sight line important, or is it necessary, or?
You mean the sight glass?
Sight glass, yeah, sight glass.
For
the compression tanks. I've seen some fittings, like tanks with a vertical line.
That's for troubleshooting. It basically allows you to know that yes, there is air in there, or no, there isn't. If you don't have the sight glass, you don't know.
Are they prone to failure? Is it worth it, or just drain it every now and again, refill it?
they're not really prone to failure. I mean, they're more of a convenience. And on the residential side, sometimes you see them, sometimes you don't. You know, if you don't have a problem with popping relief valves or anything like that, I probably wouldn't worry about it too much.
So it's kind of like a yearly maintenance, drain the whole thing, open the air, and then let the boiler fill it up as much as it needs.
Often they'll have an air separator here, which I don't show as well, that'll pull air out of the system, and it sends it up into the compression tank.
I see.
You know, and Bell & Gossett sells what they call an air troll. It's a little valve with a stem on it.
With the thing.
Yeah, and that's designed to take air bubbles as they come up and send them right up into the compression tank.
I see. Okay, thank you.
Can you tell if you have a compression tank or a diaphragm tank?
It'll probably say it on the nameplate. A diaphragm tank is going to look just like a metal tank. It's just going to be, you know, I don't know how to explain
Mine's
it.
got a
If it has one of the little fittings on there for filling,
yeah,
it's probably a diaphragm.
a diaphragm. It's got a valve and a little air. What do you call it?
Yeah,
I
like
think there's a tube in the tank itself that let the
A com-
air to fill a.
then that's a compression tank.
Okay,
If it has that.
that's what I figured. Yeah. I never heard of it.
If that relief valve does pop open, as you said, and water's going down the drain, should you reset the relief valve or just call someone and find out what the issue is?
Well, they'll pop and then shut again. But
will.
the problem with relief valves, you're actually supposed to check them periodically. The problem with that is when you check them, and then you open them up and close them, and then they start to leak because debris gets, you know, and that's one of the reasons people don't test them, because they test them and then they leak, so then they have to go buy a new one, and they don't want to do that again. But the thing about testing relief valves, if you do it periodically, it most likely won't leak. It's when you don't do it,
Right.
and then come back a year or two later and try to check it and test it, is when it ends up having problems.
Okay, thanks. Thanks.
Compression tank fills up and blows your relief valve often. Is there a leak in the system?
No, not necessarily. It just means that you lost your charge. You lost your air gap.
How often you have to charge it?
It really, normally you don't have to do it very often at all. I mean, it'll last years, you know, but
I know
it does over time. That actually gets absorbed and that water level will slowly rise.
But this one is almost every year where the pressure goes up and it blows.
Are you blowing relief valves?
Yeah.
You got a compression tank problem, most likely. So you got either a waterlogged compression tank or a diaphragm, the rubber has broken, and now water's getting through past the rubber onto the air side. The way you can tell that too is if you have there's going to be a little Schrader valve, bike tire valve.
Yeah.
If you push on that and water comes out, you've got a ruptured diaphragm tank.
Oh, it's not like a tire valve. It's just you let air in.
Yeah, but if you open the wrong valve, you can actually let air out, and then you're going to make your problem worse.
Because when you open the valve, it tells you to let the air, turn the valve so the air gets in and the water drains.
Yeah, as long as it's not under pressure, that'll be fine.
For ease of maintenance in several buildings, is it worth it to change from compression tanks, which are old and rusty, to the new diaphragm type?
Nowadays, most newer boilers are gone to the diaphragm style. Yeah, because the compression tank was an older system. They're usually used in older systems, and when they fail, they typically get changed out with the diaphragm.
Gotcha. And the diaphragms, they come per size of boiler, number of apartments, that kind of thing, that you kind of size it at the store based on what you have?
There are different sizes of diaphragm tanks, yes. Most residential or even small commercial buildings don't require a really big one.
I see.
You know, but you guys sell those here, don't you, the diaphragm tanks?
If we don't have them, we can get them in short order.
You might have it, because with having the Bell & Gossett stuff that you have here, I bet you probably have them. The other thing I didn't talk about was the low water cutoff. Low water cutoffs, you're going to find them on hot water boilers and steam boilers. This one actually shows two. This one's a probe type. There's a little probe that goes in the water and senses the presence of water through a little metal probe. This one here actually has a float inside, and if there's water in there, the float goes up and it knows that there's plenty of water in the boiler. And those are wired what they call in series. This is good into electrical. Okay, you can wire stuff in parallel or you can wire stuff in series. And series means they're all together. So if you break the circuit anywhere in that series link, nothing will work in that series. Parallel circuits, you got 2 lines, and that's different. And we're not going to talk about parallel because we're not going to really bump into it on the boiler side. Everything's wired in series. So this is wired in series with the burner. It's also wired in series with the Aqua Stat. So basically what it has to be is the Aqua Stat has to be said, I need heat. The boiler level control has to have it switch closed saying that there's plenty of water before that burner is allowed to turn on. Does that make sense?
The low water cutoff, is it mandatory only in steam, or a good idea to have them on both?
You know, it kind of depends on the local codes. We're seeing more of it on any boiler. You know, on steam, absolutely.
Yeah.
100%. Hot water, it kind of depends on the local codes.
Gotcha.
You know, whether or not it's required or not.
Thank you.
You're seeing, like most commercial hot water boilers are all going to have low water cutoffs on them. Residential hot water boilers may or may not, depending on, you know, what you're buying. Yeah, and if it's also the size thing. At 400,000 BTUs, it seems to be the magic cutoff. Below 400,000, it's a little dicey whether you see it or not. Above 400,000, typically you will. Now, 400,000 BTUs is a fairly good size residential boiler, than commercial boiler for that matter, or you know, maybe apartment building type thing. Uh-oh. Okay, here's a steam boiler. Here we got our water is blue. But steam boilers are going to have a water line, okay, because above here is where the steam goes out. And it comes back around, and as it gets cooled down, it condenses. So the steam turns back to water, and then the water comes back through the backside and then back into the boiler. So it just does so. The burner turns on, it heats the water, the boiler starts steaming, steam goes out, comes back around as water back to the boiler. And these are your low water cutoffs. This is your low water cutoff here that we're talking about. This one shows a probe type, but it could be a float type as well. You know, there's different types of low water cutoffs for steam boilers. But a steam boiler is going to have a water feeder. And basically what it is as that steam goes out to the building, some of it gets lost. There's leaks or whatever, and it just doesn't come back. And over time, you lose the steam. So you lose the water that after it condenses coming back, so you need makeup water. And that's what this guy does. So this low water cutoff is going to measure this water line. If it's too low, it's going to turn the water feeder on and tell it to put water into the boiler. Once it gets above the probe, it's going to turn the water feeder off, and then it's going to allow the burner to run, so then your boiler goes into its normal operation.
For mine, the water feeder seems to not be automatically turning on. It seems that I have to go down and check the boiler and refill it with water on a regular basis.
Is it an automatic water feeder?
It's supposed to be an automatic water feeder. The boiler's only 7 years old, and it was put in with they told me it was an automatic.
Well, the best way to test for that, you're going to have a blowdown somewhere at the bottom of your boiler.
Right.
Blow the water down.
How far?
Is it a steam boiler?
Yes, it's a steam boiler.
You have a gauge glass.
Yes.
You have a low water cutoff. You know
Yes.
what you're. Blow it down until that water level drops below the low water cutoff. The low water cutoff is going to go into an alarm. It's going to tell you that it's an alarm.
It'll make a noise.
Well, usually there's going to be a light, or if it's a float type, it's just going to drop down. You won't know it.
Okay.
But if you can see the water line and you can see your low water cutoff, you can kind of know, okay, I know my water is below my low water cutoff. Your feeder should be turning on.
Okay.
If your feeder is not turning on, odds are it's plugged.
Okay.
Because it takes that fresh water makeup all the time, and there's little screens in here and filters, or little screen filters to screen out debris. and over time those can get plugged up.
Okay.
So what you want to watch is does my water feeder click, or does the light turn on? The water feeders come in different flavors,
Okay.
but if it does turn on and your water level doesn't start to rise, then you know you got a plug screen,
Okay.
a plug the valve area. And often you can open these up, and there's like cartridges in there or whatever that can come out. Sometimes you can get replacement cartridges. Sometimes you can clean them with like vinegar or something like that to get the debris out.
Okay.
But that's could be what you got going.
Okay. Thank you.
Mm-hmm. Any other questions?
One more. One more. When you flush the steam boiler at the sight glass, there's the valve to flush it out. You do it quickly. Are there other places you should flush out the boiler on the steam?
Typically, there's going to be probably 3. I mean, sometimes your sight glass, you can flush it out because the sight glass becomes a natural dirt pocket, and dirt will sit in there. And then sometimes your sight glass won't even register the real water level in the boiler because there's dirt at the lower leg of it. All right. There's going to be a bottom boiler blowdown, somewhere at the bottom of the boiler, and that's really for blowing down the bottom because all that sediment's going to settle into the bottom of the boiler, and occasionally you can open that up to flush that out. But more often than not, if you have a low water cutoff, a float type low water cutoff, not a probe type, there'll be a blowdown valve on that, and that is required from a maintenance point of view that you blow that down periodically.
Okay, and just blow it down till the water runs clean?
Right.
Is that all? Yeah.
And the thing is, believe it or not, and you know, it's the right way to do it. I'm not so sure I really feel comfortable explaining this to you guys, but you're supposed to do it while the water's warm or hot. And I don't know if you've ever blown down your boiler when it's hot. It's really not a super enjoyable experience because the water's hot.
Should the system be off when you do that?
Yeah, but if your system's off, you're not under pressure, so it won't be hot, and it won't. The reason they want it on is 1, it's hot water, so it's going to help flush better, and 2, it's under pressure because you're creating steam, so it's going to help push that debris out. If not, all you have is the weight of water to push it out. It won't come out as fast. And it may not clear, you know. So, but I'll be honest with you, it's a little more enjoyable than when it's hot.
I have a question. I have an Aqua Stat, and I want to put just a day-night timer connected to the Aqua Stat, so we don't just depend on the temperature we set. Is that possible?
What do you mean? What are you trying to do?
We run the boiler with an Aqua Stat.
Uh-huh.
We don't have the solid state circuitry. Okay. What I want to do is run the boiler at certain times of the day and not at others. For instance, 1 o'clock in the afternoon to 4, it should be off. Rather than run it with the pressure of the steam boiler, I'd like to control it with a timer.
Well, yeah, you could put a timer in there, and then you just wire it in series with that Aqua Stat, and whenever that timer is off, nothing will happen, but you're going to have that risk that, you know, what if it's a cold at noon?
I'll get a phone call.
You could do it that way. I'm not so sure. I'm saying you're likely to get a phone call.
I do anyway, so.
Okay. And so,
But you can do that. You can wire it that way.
I don't see anything I don't know anything in the codes that would say no, that I'm aware of. You know, the Chicago codes or whatever. But, you know, so I don't know if I would necessarily recommend it myself because you're basically disabling your heating system for periods of time, intentionally.
Yes.
And if that's what you want to do, and it works, okay. It'll work.
Okay. It'll work. Just use 24 volts, huh?
Well, it depends on. No, you're going to be running through dry contacts, so you're not going to have to. It's not going to be powered contacts. So, whatever you end up using for a timer, just make sure they're dry contacts and not powered contacts, because you don't want to be introducing voltage into that limit circuit, because that's going to cause problems out. There's already voltage there.
Yeah. Okay, thanks.
And what is the Chicago cold temperature during the winter time?
What is the Chicago code? What?
Temperature-wise, to keep their units warm.
That's not a code thing. That's a function of the building.
But isn't there a mandatory, like 68 degrees? They have
Oh
to-
yeah. There is a. They have to. I think it's a certain time of the year, a certain temperature. I don't know exactly what it is, but there is. Yeah, but I think it's also the time of the year too, isn't it, or is it just temperature?
They can call the city and create a real problem for you.
Yeah,
So
the city reacts to that pretty quickly
They,
too.
they sure, well, they want to write more tickets.
Oh, is that what it is? Okay.
Yeah, of course. But I would say that if you can keep it at a constant 71, in real cold weather, you should be at 72 running all the time, day or night. But
Yeah.
those are choices.
Yeah, see me, I prefer 68. My girlfriend, on the other hand, prefers 75.
Well, your girlfriend and I would get along real good.
The code can be found online, City
Yeah, I'm
Chicago.
sure you can. You can probably Google that and find out
Yeah,
that.
citychicago.org.
Yeah, I'm not a code expert, when it comes to City of Chicago. But just real quick on steam. Basically, you got water, you got air in the system, okay, and you're going to have what they call an A dimension, and it basically will move up and down depending on whether you're steaming or not. And basically all that does is that allows the water to get pushed back into the boiler, because if you didn't have it, the water wouldn't go back in. And basically what happens here is as your boiler turns on, it starts to steam. Steam starts rising out to the system. Now, here's the thing about steam boilers that you need to be aware of. You're going to have a vent, because the vent's there to allow the air to get out. Because you got air all in here, which is not going to do anything for your heating. So you want it out of the system. You want it to be replaced by steam. So the steam comes up, pushes the air out, and the air goes out the vent. And the vent does two things. It lets air out, but it also has a little thermostatic control element in there that once steam hits it, it shuts. So your vent should be venting air in the beginning, but when your system's hot, it shouldn't. If your vent's venting when it's steaming, like you see steam coming out of the vent, you might see a little puff here and a little puff there, but if it's constantly steaming, you see steam rising out of your vent, you got a bad vent. And that's wasting energy. If it doesn't vent, this air is going to get locked in here, and you're going to have cold terminal units. One of the biggest problems with steam systems where you're not getting heat out to this building quickly enough is your air vents plugged. What's that?
Is that the vent on the return side or the
Yeah,
vent
this
from a
is
radiator?
called the main vent. It's a bigger vent. There's vents at the radiators and all that too, but this is what's called your main vent. And it's really more for get the system moving, in the piping in the building. And then at the different terminal units, you'll have little vents, radiator vents.
I know that.
And
Now, if it doesn't make a hissing sound, is it still working?
It'll hiss in the beginning.
If it doesn't make a hissing sound.
Oh, it doesn't make a hissing sound at all? I would guess it's plugged. That's what I would guess. The other way too, you can feel the pipe when the boiler. Be careful before you start touching steam pipes. But when you first turn the system on, you can feel the pipe. If it stays cold, it should get warm up pretty quick.
Horizontal streamline?
See, that's a tricky question. Okay, typically it's going to be either located up high, if you got multiple levels in your building so the steam can rise up to the multiple levels, or it might be even in the mechanical room just at the back end of the return line. So it allows all that air to get through and get pushed back out the back end. I can tell you right now, you could have multiple main vents. Somebody might have put a second one in or whatever. It depends on how much piping, how big the building is. A small single level home, it's probably going to be in the mechanical room, just because you're going to push it right on through. Multiple levels, it could be up high, it could be in an attic. It's tricky. So on the maintenance side, we're going to talk about 4 topics: housekeeping, ventilation, leaks, and then regular maintenance. I'm going to start moving along pretty quick here because I'm not going to get through this presentation, which is fine because you guys had a lot of good questions, but I'm going to try to move along a little bit quicker. Housekeeping, the biggest thing is your boiler is not a storeroom. Your boiler room shouldn't be a storeroom. You shouldn't be piling stuff on top of your boiler. It's all a bad idea. Okay, you should keep that boiler clear so you have access to it and there's not a lot of clutter around it. Ventilation. When I talk about ventilation, I'm talking about two things. Combustion air, your boiler needs to breathe. It needs oxygen. And then the second thing is exhaust ventilation. You need to get rid of that flue gas. You don't want to keep that in your building. What you should never do, and I've seen remodels like this where they remodel a building or whatever and they make a little room for the boiler because no one wants to see their boiler, and they'll make a little room for it and they have the venting going out and then they shut the door. Where's it going to breathe? How's it going to breathe? You're going to end up causing a whole bunch of flame failures, flaming issues. You're going to have carbon monoxide issues because the carbon monoxide can't get out as easily. And then you're also going to eventually soot up that boiler or cause maintenance problems over time with that boiler. A boiler needs to breathe. It needs oxygen. It needs a flow of air. Now, sometimes they pull it from the building. Often they'll pull it from the building. Sometimes you'll see a separate tube that goes outside that goes directly to your boiler that pulls air from the outside. That's called sealed combustion. So those boilers need to breathe. If you don't let them breathe, you're going to have maintenance issues, you're going to have flame failures, you're going to have all sorts of problems with your boiler.
Excuse me, I have one question. Is the steam boiler better to leave it with water in summer or empty?
People ask me that a lot. Right. The way I look at it is this way. Should you drain your boiler in the summer? Steam boilers, not water boilers. Water boilers you'd obviously leave.
Steam boiler.
The thing about water in the steam system is as it's steaming, a lot of the particulates that come in with fresh water, the sediments and all that, kind of get dissolved out and fall out of the water. So the water becomes somewhat distilled and cleaner actually, even though sometimes it doesn't look that clean. But if your boiler water is really dirty, then flushing it is a good idea. If your boiler water looks fairly clean, I'd leave it in there because it's not going to have as much oxygen in it as
Does it rust more inside with water or without water?
Actually, that you'd have to talk to the boiler maker and you'd probably see what their recommendation is.
Same, no different.
Yeah, I'm not sure, to be honest with you. I typically leave the water in, typically.
Okay.
But I'm not a boiler maker. Or, I don't manufacture boilers, so.
Jerry over here.
Okay, sir, I own a 6 flat, and I usually have my boiler maintenance every year. Stoker comes out and they clean it and we'll check it, everything's working. And I noticed that I have a flute. That's what you're talking about. I have never cleaned that.
Have a what?
Cleaned that flute.
The flute?
Flute. It's called a flute, or it goes up to the chimney.
Yeah, the stack.
Yeah.
The vent.
I
stack.
have never cleaned that. And the stoker told me, he says, don't worry about it.
Well, you don't. You're inside your venting. You normally don't have to clean unless you're having sooting problems or something like that, where it's not like a chimney where you're burning, wood or anything like that. The flue gas is fairly clean, so you don't really have to worry about that unless you're having combustion issues with your boiler, which is causing it to soot up and send that stuff up the stack. And then you might have to. But no, cleaning the stack is very, very rare that you need that.
So he was right then. Okay.
Yeah, I would probably agree with him, yeah.
Okay, thank you.
But either way, with ventilation, you really need to make sure you got air coming in, combustion air. There has to be plenty of air coming into the boiler room. Certain jurisdictions and regulations are going to dictate how big those openings need to be. The boiler maker is going to say how big the openings need to be. So if you do decide to do this, be aware that you need to size that combustion air so that the boiler has enough air. So there's more to it than just cutting a hole type thing. The boiler makers, the OEMs will give you guidelines in their manuals to tell you exactly how big that space needs to be. And really at that point in time, you probably need a contractor to make sure it's done right. You know, that wouldn't be something that I think you should be tackling as a homeowner or an owner type thing. Leaks are a problem. On hot water, they're a problem because when you have a leak, you introduce fresh water. When you introduce fresh water, you introduce oxygen. When you introduce oxygen, you introduce the opportunity to rust. Okay, and so that's why they can cause all sorts of problems, and it's going to get plugged up in places where it doesn't belong, and it's going to give you problems with operation of your system efficiencies and everything. So every boiler system leaks. I mean, it's just the nature of the beast. They typically do, but you got to try to find them and then stop them because they're only going to cause you problems down the road if you ignore it. So servicing your boiler. Here's where you're probably going to want to bring somebody in to help you. This is the kind of things that they should be doing. First of all, they're going to inspect, just a general inspection of the gas lines, the water lines, the venting, clearances, making sure you don't, the boiler is being operated in a safe environment. Then they're going to inspect it, clean it, and reassemble it. So a good service contractor will go in and actually pull the burner in certain boilers. Some boilers you can't. Atmospheric boilers you can't because the burner's underneath. But modulating boilers, they actually will pull the burner out and clean it. And they're going to also clean your heat exchanger, the boiler heat exchanger, because you want to get the dirt and all that off that heat exchanger because that's impeding the heat transfer, and that affects your efficiency. And then you end up paying more for fuel bills because it takes more heat to heat the same water because it's not as efficient in transferring through the heat exchanger. That's why the heat exchanger should be cleaned as well. And then what they're also going to do is they're also going to test your safeties. You got several safeties on boilers, like a low water cutoff is considered a safety. All right, and they'll test it. Some of the more newer boilers have a lot more safeties. They'll have low gas pressure sensors. They'll have high gas pressure sensors. They'll have high temperature. Typically a boiler is going to have a high temperature limit on it, and those should be tested periodically. And that's what when you get your service being done to your boiler, they should be testing those safeties to make sure they're all operating properly.
I have a thermostat that has 2 wires on the boiler. 2 wires connect to the middle of the thermocouple. What's that for? It's a safety.
What is it?
There's 2 wires. There's a thermocouple right in the middle of it. There's a clip. 2 wires going into the boiler.
That could be any of a number of things. I'm not 100% sure what it would be, but it could be just even checking to make sure your pilot's on, proving out your pilot. It could be thermostat wires that are turning the Aqua Stat on and off. It could be any of a number of things. I'm not 100% sure, based on your description.
Yeah, because they ordered one for me from here once.
What's that?
They ordered a thermocouple because they don't carry that around. It's an old ASO boiler, copper tubing.
Uh-huh. It might be the high limit.
Yeah, that's what
The high limit wires.
The high limit is the heat, then, if it goes too high.
If the water temperature gets too high, it turns the boiler off.
You'll shut the pilot off,
Yeah, shut the boiler down.
shut the valve off.
Yeah, most likely won't let the gas valve operate.
Thank you.
But when you look at maintenance, there's daily, monthly, and annual maintenance. Daily is just your walk-bys. You basically check the boiler area, make sure there's you don't have blockage in any of your combustion air or flue vent. Look at the pressure or temperature switch gauges and make sure they're actually reading what you think they should be reading at that particular point in time. And then just verify that the boiler's not damaged, or this is kind of just a walk-by. And you should actually, people ignore their boilers, and if you go in there periodically, even if you don't do it every day, if you do it maybe weekly, you'll notice differences. And sometimes what you notice is going to help save you from expensive repair or whatever, just by saying, hey, that's not quite right. It's like your car. When you're driving your car, you notice things when stuff's going wrong. You just notice something's wrong. You may not know exactly what it is, but you know there's something wrong. And then you can then investigate it further. Now, when I talk about monthly, these are the boiler manufacturers, kind of their guidelines, and they're a bit stringent, and there's a lot involved, but this is what they're asking you to do. Okay, so I'm just basically saying this is what is recommended. Obviously, check the venting, the air, the relief valve. They want you popping that relief valve. Even though you guys are going to get mad at me because you're going to go down to your boiler room, pop that relief valve, it's going to leak, and then you're going to say, look, Jerry told me to do that. And now you end up going to have to buy a new relief valve. But they want you to do that. Testing your low water cutoffs, they want you to test monthly. Blow them down with the blowdown. The electronic ones have a little push button that you can push the button, and it'll turn put the low water into alarm. All your safety valves, exercise any of your safeties, depending on what's on the boiler. And then on condensing boilers, there's a condensate drain, because that water has to go somewhere when it comes out of the boiler. Now, this is not a leak in your boiler. This is condensing taking place on the burner side. And that has a tendency to get plugged up and stuff like that, too. You don't have to worry about that unless you have what is known as a high-efficiency boiler, a condensing boiler. Most boilers out there haven't quite gotten there yet. On the commercial side, they are. The residential side, not as much, but they are out there. Annually, obviously, the service guy, this is where you want to have a service professional come in. Unless you feel comfortable doing this stuff yourself. Some of this you actually need what's called a flue gas analyzer in order to set combustion, and that is a device that costs over $1,000. So unless you're going to invest in a $1,000 piece of equipment to adjust the combustion on your boiler, you need to hire a qualified contractor. But they're going to do a lot of the same things, check for operation, but they're going to come down there and actually check the boiler themselves before they do anything, just to make sure they can get a snapshot of what the boiler's like. Then they're going to come in and they're going to look at the flame, they're going to look at the wiring, they're going to look at any clearances, they're going to look at the piping, they're going to look at all this kind of stuff to make sure it's all up to snuff and up to spec. A lot of this stuff here is driven by codes, Chicago codes, which your service guy is going to be knowledgeable about. He's going to have an idea of what's right and what's wrong. He's also going to remove and clean your burner. He's going to check your pilot. He's going to clean your heat exchanger. This is stuff that, is not necessarily something you can. He's going to check for any leaks. They have sensors that they call little sniffers. They can sniff for gas leaks and stuff like that. Often you can smell it yourself because of the smell of gas. That kind of stuff. Whether there's a problem with your flue pipe, you're talking about your flue, he'll take a look at that, making sure that that's okay. Then he'll test everything. But on the heat exchanger, I drive this home because it's important that they clean that. Because if they're not cleaning the heat exchanger, you can have the heat transfer of that heat exchanger is going to be diminished and it's going to cost you money. So also, if that heat exchanger is plugged up, air can't get past it. Flue gas can't get past it. So you're going to have ignition and combustion issues. And it all starts snowballing, and then it starts sooting, and then you have more problems. So they definitely should be cleaning the heat exchanger. And they can clean it in many different ways, Hang on. Let me skip that one. Sometimes they'll just vacuum it out, depending on how dirty it is. Sometimes they'll use water on it. Like condensing boilers, they're typically going to use like a garden hose and flush it out. Sometimes they'll just use nitrogen gas, which is a way of blowing it out. It's just an easy way of doing it. And sometimes they may even mechanically clean them if they have to. But there's lots of different ways, and the manufacturer recommends how to do that. Then your burners, these are some pictures of some burners, different types of styles of burners. These are more your modulating type burners. These aren't your atmospheric burners that just have the rib of flame, a rose of flame underneath. These are more sophisticated. But if you look at your burner, it's going to have a gas train and a blower. That's what a blower looks like. I talked about that earlier. But these are boilers that are a little more advanced. You know, these aren't going to be your typical atmospheric boilers, and you might not have anything like this in your building. But the same idea to clean them. You can use water, vacuum, nitrogen. But here's the thing. They're going to set combustion. And they do that like a car, you know, when they stick that thing in your tailpipe to measure the exhaust coming out of your car. Same thing they do for boilers and to check the flue gas coming out. And what they're looking for is a certain O2 and CO2 and CO readings to say that the combustion is stable and efficient. To do that, you need one of these. And these aren't cheap. So this is really something that should be done by a professional. I don't think so. I would probably not. There's a liability that goes with doing something like that, you know, because they don't want just anybody. One, they're expensive. They range from $1,000 to up to $4,000, depending on the complexity and what you know. I have one that's actually $3,200. That I didn't buy it. Compliments of the company I work for, but they are really pricey, and you have to know how to use them. On venting, you got several categories of venting. If you got an atmospheric boiler, you're going to have a thing called B-vent. B-vent is just basically what it is the pressure inside is negative. So they're just using as the flue gas rises, it actually pulls on the venting and creates a negative. And that's what sucks that flue gas out of your building. Okay? So if you have an atmospheric boiler, you're going to have B-vent or category 1 venting. If you got a condensing boiler, now you're going to be in more sophisticated stainless steel venting. That's how you'll know the difference. If you stick a magnet to it and the magnet sticks, it's probably B-vent. If you don't, you stick a magnet to it and it doesn't, it's stainless steel. High efficiency on this side, and they're sealed because the pressure inside that stack is positive, not negative. Probably 90% of the folks in this room have B-vent. Now the thing about boilers is you want to watch for, if you look on the outside of the venting, look for rust, because that's telling you one of two things. Either you're getting water coming down, you know, from the atmosphere, just rain, you know, so because often they'll have, you know, a rain cap on there to stop that, or you're condensing, which is a bad thing. You know, the boiler will condense once in a while, so you may see a little bit of water, every little bit of very little traces. If you see a lot, you have a problem. And that means that the boiler is condensing and the venting is not designed for that. And that's not good. You might also, in some of your boilers, they got what's called concentric vent. And concentric vent actually has the flue gas and combustion air together. So the boiler pulls this air in on this side and exhausts out the same end. It's just it's a pipe in a pipe. High efficiency applications. So if you don't have a high efficiency condensing boiler, you're not going to see this. The other thing you got to be aware of is where you locate your vent. There are rules for that. That you only can put it in certain locations. You can't put vent under a window. So the boiler's venting combustion or flue gas is underneath the window, and somebody decides to open the window. Well, guess what? That's a problem. You know, they don't want you putting it over doorways because they can drip, and then it freezes, and it creates a slip hazard. But these are codes driven by NFPA, National Fire Protection Code. So these are rules that have to be followed. So if you decide to move your boiler or move the venting, don't just move it to what's convenient. Move it to the place that allows you within the codes. And that here again, you should be using a contractor.